All right, we're given an initial value problem, a differential equation with an initial condition, and we're supposed to use Euler's method with step size delta x is 0.25 to come up with an approximate value for y of 1. So it'll be helpful to make ourselves a little chart here. Xi, yi. And then we need dy dx, the slope of the tangent line, which is given by the differential equation y minus 2x. And then delta y, which is dy dx times delta x, which in this case is always 0.25. And then my new yi is my old yi plus the delta y, change in y. Okay, so I'm starting with an initial value y of 0 equals 1. So when x is 0, y is 1. And I'm going to use a step size of 0.25 till I get to an x value of 1. So this is going to be 0.25, 0.5, 0.75, 1. All right, now I'm going to work my way across the first row. So my initial value is when x is 0, y is 1, and I'm going to calculate dy dx based on those two values. Y minus 2 times x. So y is 1, x is 0. So dy dx is 1 minus 2 times 0, which is 1. My change in y is the dy dx I just calculated times 0.25. So 1 times 0.25 is 0.25. And then my new yi is my old yi, which was 1, plus my change in y, 0.25. So 1.25. And then I take that 1.25, that's my new yi. Calculate dy dx based on my new x and my new y. My new x is 0.25, my new y is 1.25. So I do 1.25 minus 2 times a quarter. So it's 1 1/4 minus a half, which is 0.75. Calculate my change in y, which is my dy dx, 0.75, times 0.25, which is 0.1875. And then my new yi is my old yi, 1 1/4, plus my change in y, 0.1875, and that comes out to 1.4375. And I write that down here. And then do the whole thing again. Y minus 2 times x. So that's 1.4375 minus 2 times a half, so that's 0.4375. Delta y is dy dx times 0.5 times 0.25. So that comes out to 0.10935. That's this number times 1/4. And then my new yi is my old yi, the 1.4375, plus the delta y. So that comes out to 1.546875. Notice I'm not rounding anything. I'm keeping every single decimal place that my calculator is spitting out. And I want to do that until the very end. I'm not going to round anything because rounding errors can compound. So I'm going to write that 1.5 number down here, 1.546875. My dy dx is that minus 2 times x. So that 1.54 number minus 1.5 leaves me with 0.046875. And I'm going to multiply that times 0.25. And I get 0.01171,875. And then I add that to my old y. So I get 1.55859375. That is the y value for my x value of 1. 1.5585937.5. That's my approximation for y when x is 1. So I'm done. So it's easy to forget when you're done and that you don't have to fill out the whole rest of that row.